Hi everybody, this is group 14. I, Siavash with Hadi and Ghanem are going to present our project. Our project is about surgical robots. In this project, we are going to do a several application and classification of different surgical robots used in industry. And in the next step, we are going to design an analysis of a serial arm for a specific task in surgery. In the early 1980s, surgical technique experienced a revolution called minimally invasive surgery. The goal of minimally invasive surgery was to reduce patients' pain and recovery time from surgical procedures by minimizing the trauma of the large incisions required by conventional open surgeries. The first recorded robotic surgery took place in April 1985 at Memorial Medical Center in Long Beach, California. Robotically assisted surgery was developed to overcome both the limitations of minimally invasive surgery or to enhance the surgeons to perform open surgeries better. As you can see here, these devices could have different applications in the surgery, in general surgery, cardiac surgery, neurosurgery, urology, and orthopedics. This picture shows the application of the device in hip bone drilling. Here we can see the robot which is taking pictures from inside of the vein, which is using cardiac surgery, and this picture shows the application of the robot in neurosurgery, which is guiding a probe through the brain. Now we're going to talk about the pros and cons of using of the robots, which Hadi will explain to you.
Application of surgical robots has a number of advantages and disadvantages. Among the advantages, we can mention to repeatability, stability, and accuracy, tolerance of ionizing radiation, diverse sensors, optimized for practical environment, ease, manage multiple simulation tasks. And among the disadvantages, we can mention to being expensive and inconvenient, large and not versatile, and the most important, unable to make decisions. Surgical robots can be classified in three different ways. First, we can classify them based on the functional base, which we can tell them that they can lead to enhancement of the dexterity and precision of surgery. For the technology-based classification, we can classify them to the autonomous, supervisory, and teleoperated robots. And for the role-based classification, we can classify them for the passive role, restricted role, and the active role. In the passive role, the role of the robot is limited to in scope or in its involvement in largely low risk. The restricted role is when the robot is responsible for more invasive tasks with higher risk, but it is still restricted from essential portions of the procedure. For the active role, the robot is intimately involved in the procedure and carries high responsibility and risks. Now, Ghanem continues with the application of types of robots.
We will start first with a CT scan. The computer tomography is a familiar imaging modality in which a manipulator articulates a scanner to different locations to obtain various cross-sectional images of a human body. And one of the companies Zeta Medical Technology is one of the pioneers in production of CT scan. The second type is going to be the CyberKnife. The CyberKnife system is a non-invasive radiosurgical device for tumor destroying. It is a unique device that integrates robotics with image guidance technology. It is approved by the Food and Drug Administration, the FDA. The third type, we have the RoboDoc. Curix Technology Corporation covered the robotics production since it is used for bone milling portion of a total hip arthroplasty or any application in the orthopedic field. It is an image-guided system that pre-operatively requires the surgeon to view a CT images and select the appropriate implant and its placement. Now we're going to talk another type. It is the NeuroMate. It is another image-guided system that uses an anatomical landmark for manual registration. The function of the NeuroMate is to determine the location of the insertion of a drill, probe, and electrode base on the pre-operative images of the neurosurgery. Renshaw, one of the world's leading engineering technology companies, dominated the production of the NeuroMate robot. And those two images covers the Da Vinci system. Intuitive Surgical INC spearheaded the Da Vinci system production. It is a teleoperated system in which the surgeon sits at a remote console on the side of the operating room and directly controls the motion of the instrument in a surgical field on the other side of the room. And it covers most type of operative surgery. As you can see in this animation, this is the Da Vinci robot peeling a grave and shows the accuracy and the precision of such a system. Now, we're going to go through the design of the serial arm with Siavash going to present.
Here we are going to choose a specific task for our serial arm, which is going to be locating tiny pieces of metal in flesh, which is caused by shrapnel injuries, and to guide the device to take those tiny pieces out of the patient's body. Here we can see the required pass of our end effector, which is along this semicircle. Consider a patient lying on this bed, so the end effector is going to move from the left hand side of the bed in a semicircle to the right hand side. In the next slide, we are going to show the design parameters. As you can see here, we have chosen our link links, which is A1, A2, and A3, and also the height of the support of the mechanism, which is measured from the center of the bed. And the end effector is going to move on this semicircle, and it's going to be always perpendicular to its path. Now the inverse position is going to be described by Hadi.
These two diagrams have been obtained by using the inverse analysis of the system. In the first diagram, the first diagram shows the angle of the first link, and the second diagram shows the angle of the second link, based on a function of the end effector position for both the closures. As we can see, there is no jumps or singularity in the diagrams. And in this diagrams, the trajectory path of the end effector has been shown based on a function of the x coordinate of the end effector. And here you see 4 different closures of the robot. Now Ghanem continues with the robot in motion.
Now, as you can see, it's still in a semicircle path, and we can use such application and by plugging in through the manipulator a camera tool or an insertion tool. To sum it up, robotic technology is to change the face of surgery. Future robots are going to become a mandatory equipment, common operation in a different field. The need of such technology urged the industrial companies to race time and each other to come up with all types of surgical robots, yet to narrow their task to various applications. The surgical robots, as an important device, in the minimal invasive surgery has helped to reduce patients' pain and recovery time from surgical operations. And thanks for listening.